We are live. You're watching a new segment that we're putting together called the Interchain Jam. In fact, it's not really new. It's just Interchain FM syndicated to the Interchain YouTube channel and the Cosmos Twitter account. So you're going to be getting the same alpha that you got from the Cosmos radio station, just on more channels. So if you're seeking alpha in the Cosmos, look no further. I'm your host, Chjango Unchained. If you're new to Interchain Jam, this is where we host the voices and the people behind your favorite projects in Cosmos. We will be streaming these on a bi-weekly basis starting this month, April 2023. But before we get started, if you enjoyed this content, you could support this channel by staking with Interchain FM on Osmosis, Comdex, Umi, Canto, and the Cosmos Hub. It helps us bring you this on a bi-weekly basis so that you could derive as much alpha as you can through the bear market. So enough about that. The Interchain Jam is a podcast covering IBC, and that's what we're here to talk about today. We have now 274 app chains, and we started with only 4 app chains, that being Binance Chain, Cosmos Hub, Iris Hub, and Crypto.com, Kronos. And Cosmos ecosystem was largely a ghost chain before IBC was launched. So we went from 4 to 274, and the space is only growing. Today, we have guests from all across the ecosystem, including Dogemos, Chris Goes, Susannah from Interchain GmBH, and Bo from Polymer DAO to talk about IBC as it turns 2. You are watching history being made right now where the interchain is starting to converge around the TCP/IP of the Internet of Blockchains. So welcome, guests. Let's start with you, Susannah. What's your background and how did you get into Cosmos?
So I actually only joined, probably I'm one of the newer people to Cosmos here. I officially started my role in Cosmos last May. And before that, I was working with a validator, a ZK validator who was validating on the hub. And before that, I was doing a PhD in bioprinting, so absolutely nothing to do with blockchain or cryptography. And yeah, then I just moved over and here I am.
Very excited. Chris Goes, how did you get into Cosmos and what's your background with IBC?
Right. I guess there are 2 steps to the story. I learned about Cosmos during some hackathon before the launch of the Cosmos Hub when I was extremely broke and needed a way to pay my New York City rent and was trolling for hackathons. And honestly, the reason the hackathon appealed is that it had a large prize pool, not going to lie. But I got pilled, or so to speak, into particularly the concept of IBC, which is what I originally joined All in Bits back I don't know, whatever it's called now, but back then it was called All in Bits or Tendermint several years ago, primarily to work on IBC.
Yeah, hackathons are the greatest user acquisition tool out there. So, Bo, who are you and how'd you get into Cosmos?
My background's been in distributed systems and database systems. So before blockchain, I worked on an open source time series database called M3. Worked a little bit in DeFi. Was actually trying to build a separate interop protocol. Realized that the design looked very similar to IBC. And then because we were already building on the Cosmos stack, and thanks to a lot of the specs that Chris Goes wrote, and a lot of the early folks in Interchain, was easily convinced that IBC was a superior solution than some of these other competing specs, of which there aren't many, and decided to adopt IBC.
That's great. And Dogemos, what about you? Who are you and how'd you get into Cosmos?
Yeah, I'm currently building a Keplr wallet. Well, also one of the co-founders of Osmosis. And I also have a completely non-crypto / Cosmos related background. I don't know, I was just making videos. I happened to be some Twitter anon making Cosmos memes, and then one thing led to another, and I did more things, and yeah. now I'm building a Keplr wallet.
Great. Okay, so we're gonna have some fun with you guys. What was your aha moment with IBC? And we don't need to go down the line per se. Anyone could just blurt something out, so we could have a normal conversation and not really a panel discussion. What was your aha moment with IBC? I suppose we could start with Chris because you're the person who designed the spec for V2. Ethan Fry was the one who designed the spec for V1, and Jake Wan was the person who came up with the idea.
Right. To be clear, designing the spec was really a group effort. The most intense part of it, as I recall, was a 2-day sprint in Berlin in the summer in full node, which is a terrible idea. Don't do this. It's hot and there's no air conditioning because Germans don't believe in air conditioning yet. They're starting to, we had a whiteboard and let's see, Ethan and Sarko and the Agoric folks and June and I and a bunch of people who I'm not remembering everyone. Had a pretty intense 2-day design session, and really most of what I did with the specs after that was just kind of writing down and refining all of those diagrams that we had put together. And there was stuff in that design session like proxy clients that, as far as I can tell, is still like an issue on the ICS repository, right? Like it hasn't even been instantiated yet. So much of what happened in the IBC specs is downstream of that. As the idea for IBC predates my involvement in Cosmos, so I don't know all of the backstory. But when I joined, Ethan Fry, who had at that point left all in bits, but had written an initial kind of spec, and I, worked from that, and I worked from the idea, and I, got lots of input from Agoric, and tried to make, at that point we really had. We were working, I would say, in a very abstract design space because there weren't necessarily specific things that people wanted to do with IBC. I mean, people thought they wanted to do token transfers, which is fine. But I was just very, I did not want token transfers to be the thing, like IBC should not only do that. We might as well. Protocols are scarce, right? Like, there are 274 app chains, but most of them are using the same protocols, right? Protocols are the things that are really scarce. As you said, maybe there are not even that many, serious alternative specifications for something like IBC, right? So I thought it would be good to kind of design something that handled as many cases as possible and did them as neatly as possible and fit the abstractions together cleanly so that it could be extended in the future. And I tried to do that. I think that, looking back, there's I think lots of interesting lessons you can draw from watching protocols in the wild. One shout out to Agoric, who asked for Solo Machine clients, and so we built Solo Machine clients. And Agoric, you better use Solo Machine clients. I want to see it. I want to see these like robot swarm drones or something that Mark Miller was talking about because we built it for you. So,
sorry, what are Solo Machine clients?
What are Solo Machine clients? Well, Solo Machine clients, I guess I don't want to go too far into the rabbit hole of ranting about things, so please stop me. But Solo Machine clients are ways just for single accounts, like private public key pairs, to speak the language of IBC. That kind of reveals an underlying unity, you could say, between blockchains and accounts. They're actually the same thing. They're sort of machines that sign messages using some kind of algorithm that other parties can verify. That's the kind of the essence which IBC abstracts as clients. And right now, I think the Cosmos SDK still has many distinctions between user accounts and IBC chains or Solo Machine accounts, but perhaps those will become more unified in time.
Great. All right. So anyone else? What was your aha moment with IBC? Why do you use it?
I think for me, like when I first found out what IBC was, like I'd come from learning predominantly about Ethereum. And when I started in my role as a validator, I was exposed to lots of different proof of stake networks. And that was kind of a bit of a eye-opener to me because it's like, Ethereum, Bitcoin, and then it's like all of these other blockchain topologies exist. And coming from like a manufacturing background where it seems like in any like kind of production system, it's like a really bad idea to make something so big that you like can't really change things or things can't be easily like switched in and switched out. Like this whole kind of modular concept just felt like intuitively to make a lot more sense to me, and having chains that are really well like tailored for a specific purpose like seemed to me to intuitively make more sense than like having one massive chain that does everything. And the real like fundamental infrastructure that like makes that whole concept work was IBC. And so when I kind of realized that and then started to like learn more about it, then I was like, okay, I want to be working on IBC, because I think that's like the most important protocol for this whole like app chain thesis, and small parts coming together is actually going to make it work. So that was like my aha moment. And I remember it was like I was actually reading about IBC for the first time around the launch. Like I was like not aware of like the whole development going on, but then I remember I was like at the same time it was like Gravity Dex, IBC, Gravity Bridge was even out there. I just remember reading a lot of stuff and I was like, oh, okay, this IBC thing seems like the most interesting of all these things, and probably is. It's the one that's like staged 2 years on. So yeah, that was my moment really.
Perfect. And what about you, Bo?
Yeah, my answer is going to be quite short. I was looking at a few different options at the time. It was a difference between looking at the IBC specifications, which were quite well written, and the comparison point was XCMP at the time, which they had. I think it was probably like a one pager, like not a real specification, just an idea. And I was like, there's no comparison here. Yeah.
I mean, isn't the difference between XCMP and IBC that XCMP only works among substrate chains within
Yes,
the Polkadot ecosystem? So it's not really generalizable. You can't take that specification and use it between Ethereum and Ethereum rollups and between the EVM and IBC ecosystems like IBC can.
Yeah, that's correct. They have a more generalized form, XMP or something. But I believe that there's also no formal specification for that, nor is it implemented anywhere.
Yeah, and anyone who called Cosmos a ghost chain 2 years ago is eating their words, because now who's the ghost chain? Dogemos.
Cosmos
what was your
versus
aha
Polkadot
moment?
is like so 2019.
Yeah,
Yeah.
yeah, it's not a ghost town anymore. All right, Dogemos, what was your aha moment?
For me, I think it was just working with Tony on. I don't know. I mean, he
Tony,
came
your
up with it.
co-founder.
My co-founder. Because he was trying to, we're trying to come up with a liquid staking solution, and we're like, all right, how do we do this over IBC? And one of the ideas that was kind of being thrown at the time was interchain accounts. Prior to that, I knew that IBC was cool. It was kind of the most generalizable, like protocol agnostic form of interchain communications. I think the fact that you could just do so much more than just like move one token from one chain to another was kind of when I realized how powerful this could be further down the road.
Right. And what was your little trivia about making the first IBC transaction on mainnet?
Yeah, so apparently there's kind of a lot of different ways that you can technically say like when the first IBC transaction was made. I think, I'm sure the first real IBC transaction is something on Chris's computer or something. I don't know, like while he was testing IBC in development. So the transaction that I made was when the Cosmos Hub was the first chain to enable IBC transfers. And what I did back then was, as soon as IBC transfers were enabled, we basically ran an IBC channel between the Cosmos Hub and a hackathon testnet that was going on. So the it was the first IBC transfer of the Atom, but it wasn't between two mainnets. So I think that's the kind of technicality that I'd probably have to put there. But it also kind of opens up this new, thought experiment of, is anything a testnet anymore if you can move real tokens to it, kind of thing, right? So who knows?
Right. What happens if you have testnet tokens that are real become mainnet tokens? I don't know.
Yeah. Well, and the thing is just like, I mean, that kind of brings it back to the entire like construct of, anything that has value is just a very social, it's a social agreement by nature. So yeah.
Sure. And there's a whole testnet chain called Kusama that has mainnet tokens effectively.
Yep.
Great. By the way, to anyone who's viewing this live, if you have any questions, go ahead and put them in the chat and we will get to it at the end of the show. If you want to speak to any of the speakers, go ahead and put that there. All right. What are your favorite trivia about IBC that few others know about? Anyone besides Dogemos? Because I think you've already answered that. Everyone thinking hard. Okay, we'll get to that later, but what's I mean, I think there's a lot of bullishness around IBC, but in 10 years from now, where do you think that all of this is going to lead up to? Where are we headed? Why is IBC so relevant now, and why will it be relevant later? What do y'all think?
I think, like for me, it's like there's loads of different kind of interoperability solutions or interoperability chains, XLR, like Tron, multi-chain, all of these different solutions. Some of them have kind of trust assumptions to a different extent of IBC, but ultimately there's lots of people trying to solve this problem. But I think the power of IBC is the trust minimization. It's kind of like trust the chains that want to communicate with each other. And it's like it is a rent-free protocol. It's like you don't have to rely on this intermediary that one day they could just say, okay, we're going to put the fees up for anyone that wants to use our interoperability protocol, like 10x or whatever. Like there is some element of gatekeeping if you're just prepared to trust one of these other solutions, and you just don't have to do that with IBC. And I think that's like a key component to the future being there will be like kind of lots of different chains all just connected with IBC, not just Cosmos SDK chains. I think that's the real element that's going to put us on that trajectory. And with these things, it's like nothing ever worth it was easy. It's like the reason it takes time is just because like it's harder to build this trust minimize protocol and implement it on different blockchains than just using like the easier solutions of, I don't know, like a threshold signing scheme or a multi-sig bridge or whatever like people have opted for in the short term. So yeah, that's my hope for the future.
I'll share my aha moment. And that moment was when I made the first IBC deposit with Osmosis. It was taking Atom from the Cosmos Hub chain and depositing it into Osmosis in effectively one transaction without needing a bridge. And so when you compare that to the user experience in the EVM paradigm, where it took 40 minutes to bridge wrapped ETH onto Polygon, and then to move that around, put it on, send it to a DEX on Polygon, and then to have to bridge it back and then settle on ETH. That whole experience took half a day and over $150 in gas fees just to make that bridge transaction. And when you compare that to IBCing from one Cosmos chain to another, which costs maybe not even 20 cents, that it's night and day. And so when more people from outside of the Cosmos ecosystem wake up to that fact, it's easily a paradigm shifting reality. So, and that's what I'm looking forward to with what Squid Router is going to do too, right? Fig from Squid Router demonstrated a 5-step transaction moving from I think it was like the Avalanche chain to a Cosmos chain in 20 seconds, and it cost a negligible amount. That was I think that just blows the UX of bridges between like rollups and ETH1 or ETH2, sorry, out of the water. Yeah, what's been your experience?
Yeah, I can comment on kind of like our vision for the future. It's a little bit different from some of the things that Susannah mentioned, which are inherent properties of IBC that are very valuable. We're mostly focused on standardizing the industry around IBC as a transport specification. If you look at all of the IBC course specs, they are quite analogous to TCP/IP at the transport layer in the OSI model. The idea is that we want every blockchain to agree on a common language. TCP is that language in the Web 1 and 2 side, and we believe that IBC is going to be that language on the Web 3 side. From our perspective, IBC is technically client type agnostic. Like Chris Goes mentioned earlier, you can have a solo machine client. It can represent a threshold signature. It can represent all sorts of different things. What's important is for everyone to speak the same language so that a transport commitment generated by chain A, regardless of the ecosystem, is understandable by any other chain in the IBC network.
Yeah, outside of the IBC ecosystem that operates Tendermint-like clients, though, how do we translate that into the EVM paradigm?
Yeah,
So
I can comment. Yeah, sorry, go ahead.
Yeah, no, go ahead.
I can comment briefly on it. The strategy that we've taken is that we can't force Ethereum to have single slot finality, obviously. But what we can do is we can provide an eventually consistent view into Ethereum state. So internally in Polymer, we have the two different light client concepts, actually. We have the concept of a native light client, which tracks the full chain state of Ethereum, all the forks, up until true justifications of a block. And at some point, this view will become finalized. And then we also have a virtual light client, which implements a fork choice rule over the non-finalized state of Ethereum. So this is like these two things that interplay together.
Okay, so the first light client is your vanilla garden variety ETH light client. Does it use Infura or reference Alchemy or something like that?
The source of the header is not as much of an issue. Although to be transparent, because we're following the Altair light client, the sync committee signatures are they're somewhat constrained in terms of behavior by the block producer, but they're not completely trust minimized. It's not the full security of the Ethereum network, unfortunately. We're working on ways to improve that. But yeah, the headers can come from anywhere. You would to attack the system, you would have to attack the sync committee directly, and attack the block producer producing the Ethereum block. So it doesn't matter if you get the headers from Infura, Alchemy. That's not where you need to attack. You need to actually attack the sync committee validators and such.
Got it. Okay, and the latter virtual light client, how are you implementing that? How does that I guess work with IBC?
Yeah, so there's an expectation on the IBC side that at each block height there's a single consensus state or single blockchain state. Because Ethereum can have multiple essentially states or multiple forks at a single height, that's captured in the native light client. The virtual light client, like I mentioned before, implements this fork choice rule, so it'll only present a single consensus state per height. which is eventually consistent with Ethereum's view.
So yeah, how does the fork choice rule work? Like, which fork does it choose?
Yeah, so actually, interestingly enough, the fork choice rule depends on the chain that we're dealing with. For Ethereum in particular, we're actually using an aggregate view. Since we're saying that we'll take all the views of Ethereum in the short term, it's very hard to determine the canonical fork in the short term. So we'll take the full view of Ethereum, all the forks that we're aware of, track those. Once we get to finalization, you essentially revert back to the finalized chain and then start from there. So you always work off of this finalized view, have this kind of temporary view that is contains information from every fork that potentially there will be a reorg. This would be made transparent to users. This is a risk. This is a risk with every interoperability protocol, regardless of at what latency you decide to use a bridge that's coming from Ethereum. This is going to be a risk for everyone. But at least for us, we're making the risk quite transparent, and we're also always working off of the finalized state of Ethereum.
My understanding of the hybrid Casper that they have working in prod does work like that. So how is this different from that?
Yeah, so if you want to relay a block below two justifications, I think it takes about 12 to 18 minutes to get to finalization. So if you want to relay within a minute or a few minutes, then you run the risk of potentially having the transaction that you relayed be in a block that's reorged out of the canonical chain. That's the only difference. But because at some point it will get finalized, we'll always update this finalized view and always work off of the tip of the finalized view, but also maintain this shorter term. So for example, you can establish multiple IBC connections, one to only the finalized view. This is a very safe route. If you're doing ICS20, if you're doing token transfer, this is what you want to use. You don't want to use something with lower latency because it's just too risky. If something, perhaps you're trying to relay a transaction that has less value, that's ephemeral, you may be willing, as a protocol, you may be willing to take on the risk of relaying at a lower latency.
Got it. All right, so that's your workaround to make Ethereum-like clients pretty much speak 7-second finality Tendermint.
Yes.
Yeah, I think it's interesting to kind of think about the political economy of finality or something like that. This is not just an assumption that interoperability protocols make. It's an assumption that people make when they see an Ethereum transaction and they accept it, right? And perhaps the only difference with interop protocols is that there's some public visibility into how much value might be, thievable if you can reorg blocks, right? There could be some, whatever it's called, time bandit MEV attack concerns there. But otherwise, long times to finality are, in some sense, an exit tax, insofar as they're by choice on eco. Not saying it's good or bad. It's just the economic structure of what's going on, right? Or to some extent, they are disregarded by users up to some marginal 99.9% reliability rate, which is concerning because it creates this great discontinuity in the space of expected behavior, where users are going to get used to the most of the time is fine, and then sometime there's going to be some large number of transactions which could be profitably reorged, and someone's going to do it, and then everyone will be stunned, and they'll call it an Ethereum hack or something, which is not. But it's dangerous to create this expectation mismatch, because users and even often other protocols or operators of those protocols don't necessarily account for the black swan cases, right?
And we could go into the edge cases in a future episode, Bo, and we could kind of expound on the security guarantees of this protocol. Chris, what are some alternative implementations to translating IBC to EVM-like client, like the ZK IBC protocol that's or like client that Electron Labs is building? I want to talk a little bit about that, because that part, it seems exciting, but I want to unpack it a little bit for people who don't speak that language.
Right. Maybe it's worth just noting a few distinctions, as the terms often carry confusing association. So ZK IBC, in the sense in which Electron Labs talks about it, is using zero knowledge to compress the computation required to verify block headers. So it has nothing to do with privacy. This is not about privacy of user transactions or privacy of assets or anything like that, at least as far as I know what they're working on. They could be doing other things that I don't know about. But as far as I know, what they're proposing is merely to compress, I think they're trying to compress Tendermint header verification on Ethereum. Because right now, to verify Tendermint headers on Ethereum is very expensive because you have to iterate through a bunch of signatures, and they're not necessarily the kind that Ethereum has fast. It's expensive for like kind of random engineering reasons. Just the protocols were not made to fit cheaply with one another. Not fundamental reasons, but unfortunately, because it's hard to change the EVM, we have to kind of resort to alternatives. And one very good alternative is potentially to use zero knowledge proof just to compress the header verification. It's also worth noting this is a kind of orthogonal dimension to latency constraints of Ethereum IBC interoperability, which are going to primarily be on the Ethereum finality side, not the Cosmos finality side, as Bo has already outlined. So these two are sort of complementary solutions. You need both an Ethereum-like client running on the Cosmos side chain and a Cosmos or Tendermint Comet, whatever we're calling it, Comet 2. There must be many comets, right? It's a good comet. Hail Halebab. I don't know how to pronounce it. They should name their versions after specific comets, right? Anyway, on the Ethereum side, it would be very cool if someone were doing ZK IBC for private transfers. So far, this is just a topic that people discuss on panels. No one actually does, perhaps because there are very few privacy chains in the Cosmos, but some more are coming soon. Namada, Penumbra, maybe more that I don't know about, which would be great. So maybe there'll be more reason for people to talk about the other kind of ZK IBC in a year or two.
I mean, how viable is it to use ZK just as a compression mechanism and adopt that for something like what Polymer is doing?
Yeah, we also have a ZK-like client for Tendermint, a full implementation. The one proposed by Electron Labs is just for signature verification. The full implementation of the default Tendermint-like client would require proto encoding and decoding and a bunch of other stuff. We have a Tendermint fork that produces headers that are easier to convert into a circuit. So proof generation times for us for Tendermint-like client headers, or for the non-adjacent verification algorithm, are around 3 to 4 seconds on commodity hardware, basically on my laptop. And on-chain verification costs around 300K gas. This is still expensive. If you were to do it at 30-second latency, I think it's around $10 million a year right now. So it's not cheap, but it is cheaper. If you were to do verify the default algorithm on chain, I think it was 26 million gas. If you were to optimize the signature scheme using Tendermint, you would get around 4 million gas or something. So this is still orders of magnitudes cheaper. We also have a internal project called ZK Tree, trying to basically share the verification costs with other ZK solutions. So we're attempting all sorts of different ways to make this cheaper. But one caveat I'll add is that like ZK IBC to us is not ZK-like clients. I think ZK-like clients can fit in the context of ZK IBC. ZK IBC to us is a ZK implementation of the IBC transport layer. We're trying to have a fully ZK like IBC core implementation, and we're working towards that.
So would that be a subset of what you're building?
Yeah, that would be a subset of the protocol that we're building. Essentially, we're trying to make it very easy to integrate IBC into different chains. Integrating it natively is hard to do. We could submit an EIP and like change the code in Geth, but like depending on like when it's actually going to get accepted or if ever. But it seems that it's possible to do all this computation off chain and prove it on chain with the ZK proof. Not just the client logic, but also the transport logic.
So like packet processing, handshake authentication,
yes,
stuff like this. Very cool.
Yeah,
I didn't know you were doing that.
All right. And did you know that IBC Archive is using AI to archive and edit over 950 hours of Cosmos spaces all across the ecosystem? Does anyone have thoughts about what AI holds for the future of blockchain technology?
Hopefully
I
more
cannot
than bad
decide.
NFTs.
Oh, what? Go ahead.
Hopefully something more than bad NFTs.
Mm.
You know, on odd numbered days, I'm more annoyed with the word AI, which means nothing specific, and on even numbered days, I'm more annoyed with the word blockchain, which means a linked list, and like somehow is used for this whole other thing. I mean, what do I think AI will do? I think it'll allow us to write faster ZK circuits. It's actually very useful. It's like it will make it more reasonable to auto-generate proofs for languages with real type theories, unlike Solidity, and it will allow us to generate faster circuits. It's very good at it, you know. Some DeepMind thing recently found a better matrix multiplication algorithm, right? Like it's very good at sort of what's it called? Thermal annealing, or whatever the physics thing is, kinds of like stochastic gradient descent search problems.
Okay, well,
Simulated annealing, that's the word.
Yeah, we should disambiguate AI from AGI. So we're not talking about anything sentient just yet. What do you think the future is going to hold if we have AGI?
I mean, I
No
think
comment.
a interesting question, right, is this like a question of private information. So if we ask whether or not, you know, AGI, if we ask whether or not some entity with perhaps superhuman information or compute or processing power of some kind could, you know, interface with IBC, which is a relevant question for this podcast, then the question is, can they hold private information, right? Because in order to act as a Solid machine-like client or as a blockchain or whatever, you know, the blockchain has validators who know their private keys, and no one else does. Solid machine has a private key, right? So the question is really, does the AGI have access to private information? And if, you know, if we're talking about GPT-4, you know, to me the answer is no. I mean, OpenAI has access to private information, right? They have keys, and the keys decrypt stuff on their servers, but the people who know the information that allows them to decrypt that stuff are people. It's not GPT-4. GPT-4 doesn't have any private information. So I think that's like an interesting distinction.
Well, but they don't have the keys to other people's servers.
I hope not, but GPT-4 doesn't, right? So if you know, if you make a AI and give it or make a large language model, my question would be, how do you give it private information?
Well, maybe you don't need private information, but what do you think the clash between AI and blockchain technology is going to look like in a world where both are fully mature? You know, do you view people potentially using AI to crawl through all of the DeFi protocols and try to accumulate as much wealth as possible? And is that going to be the edge that someone has over another arbitrager? Like how is AI going to work with blockchain tech? Now we're theory crafting.
I mean, I think it will make transparent blockchains less appealing than they already are. At the moment, the costs required to effectively surveil transparent blockchains are still high enough that they can only be borne by bureaucracies with large amounts of money to spend, such as the American government. But LLMs will drive them, and already are driving them down. I mean, there are companies whose business model is like search people's blockchain account, which I don't know why you would do that, but on the other hand, it's making the case for privacy, so I can't complain too much. LLMs will just make this, it's just accelerating the information processing power, which is afforded to people who are going to use it to try and make NFT price predictions or dumb shit, but it will still make the case for transparent blockchains even less strong than it already is. Something like that.
I would agree with that. Does anyone else have any thoughts about that?
I mean, at some point, the AI algorithms are just going to be fighting with themselves. Just like how like the HFT algorithms generally, you have to kind of one up each other. It's just going to be like these like algos like trying to algo each other, I guess.
Yeah, I mean, it's a bit unfortunate when you think about it, because at some point, if the algorithms can be freely copied, it starts to look like, you know, another proof of work just under a different name, right? So I think there's a negative externality concerns to be determined.
Susannah, Dogemos, you guys have thoughts about that?
I'm definitely not an AI expert, but I don't know. One thing that kind of scares me is like, I think, you know, like crypto just really fundamentally has this thing about like determinism, right? Where like one thing becomes another and that becomes another, and like you can sort of track it back and forth with, you know, proofs, verification, and a lot of things like that. I think the AI part is like, you know, I think there are times when what happens in between does feel a little bit more arbitrary, and you know, I think that's the kind of my personal more. I'm not sure when this is even going to converge in terms of, you know, like as a helpful tool to, you know, like present technical information in a easier manner. Like, you know, hey, what if I can just feed it like a transaction blob and it can parse human readable data that we can display onto a wallet? Like, I think that would be extremely helpful. Just don't know if like AI as a chain using IBC is something I've really thought that much about, at least personally.
Sail Boy asks, Dogemos, how does Keplr decide what chains to integrate into Keplr?
It's a mix of different things, I think. First of all, we do have a limited amount of human resource internally, so we do try to kind of pick the ones that have at least long-term potential, something that doesn't feel like, oh, this is going to pump for 3 months and just rug. And then the other thing is just, you know, there are some chains where it does deviate a lot from the standard Cosmos SDK design, so a lot of the tech stuff behind it. And then there's also economics on, you know, it. One of the kind of big things around the multi-chain design that is far more difficult than kind of Ethereum or Solana single chain design is it does require us to internally run a lot of nodes, and we do that in-house, just because I don't think there is one Cosmos, you know, endpoint provider that serves every single, you know, 274 app chains. And if there is, you know, it likely isn't very reliable or stable, or when it goes down, you can call someone and they'll get it fixed. So, you know, it does come with a increasing amount of cost. So it's a mix of those things. And that's one of the things I think I'm more bullish on, like Cosmos IBC is, you know, obviously, we're not currently working on this, but it's theoretically possible to essentially have, you know, these light clients as part of the wallet itself, and you don't need to necessarily have endpoints that you plug into. You know, wallet in itself could be, you know, a light client. It could also be its own relayer. So I think these are the things where the design of Tendermint, Cosmos, in the context of IBC, has a lot of kind of bright future ahead, even though, you know, there's probably a long road ahead for us to kind of get there, in terms of kind of resilience and robustness of the infrastructure itself as well.
The node providers in across the single chain paradigm is also very spread out too. I mean, if you're thinking Ethereum, there's Infura, but if you're trying to find one coherent one between Ethereum, Avalanche, Solana, all of them, there's not like a single provider either yet. So FW Crypto asks, thoughts on Berachain and their latest tech, Polaris. Does anyone want to take this?
Never heard of it. However, when I look at your picture, I read bear chain, and I really like the idea of a blockchain for bears. They could be teddy bears. They could be like grizzly bears. I think the bears like are the next target market, and it's a bear market. So who do you go find as your next user? Is the bears. I only have a troll answer. Sorry.
I heard it's a pretty thin translation layer between the EVM and the Cosmos SDK, but I haven't like dug into the tech. I think like the less code there is to kind of interface between the two, I think the better. I also heard they have a decent IBC integration on chain, of which I have not verified.
The first time I heard of Barachain, Rick Dudley brought it up, and he and his team at Laconic were looking into Barachain because apparently it's the first Cosmos SDK EVM that is not just a fork of Evmos. So on that front, at least, they're doing original work in bringing EVM compatibility into the ecosystem. However, beyond that, yeah, I guess none of us on the panel have done any research. Right? No?
Yeah. Oh, I mean, I've seen that their logo, they use the emoji, the bear and the chain. But other than that, I have very limited knowledge as well.
How about you, Dogemos?
I haven't looked into it too much as well. On one hand, I think I am excited that there's multiple EVM compatible, state machines coming on Cosmos. On the other hand, I'm also a little bit terrified of, how much diversity there will exist in Cosmos, and like how much of this will, end up falling on the hands of like the client side and like the front end developers to abstract all of these differences, right? So, yeah.
What
luck.
do you? What do you? I imagine that there's a Cambrian explosion of that here now, but there will be a consolidation eventually in the future.
Yeah, and I think for me, even on the client side, you'll see different meshes exist, where, like even in Cosmos now, I think we're starting to see people build like governance modules on Cosmosm instead of the x/gov and different variations of it and things like that. And there comes a point where you can't literally support everything out there, if you're trying to become this like application interface. If you're just trying to be like a signer or a key manager, I think maybe that's doable. But wallets as an application manager doesn't exist. So I think the future is, you'll see multiple chains that sort of share a core, module core architecture, have, its own more kind of specific interfaces, wallets, and things like that. And hopefully you'll have multiple of these, right? So, and I think that's a good thing. That's exactly what Cosmos is designed for anyways. So, yeah.
All right. We're coming up on time, so how can people find you all?
I guess Twitter or email addresses, if probably not. Probably moved on a bit since then.
You can come to Kreuzberg, Berlin. That works.
Yes,
Oh.
you can find me on Twitter, just 0xshake.
Yeah, and I'm just at Dogemos on Twitter, and you can also find me in Flesh and Bone in South Korea most of the time. So, yeah.
All right, perfect. Well, thank you to all of the panelists who celebrated this 2-year anniversary of IBC going live with us today. And if you're listening live or later on, congratulations for celebrating this with us, because you're watching history develop as we speak, because I think IBC can really be the TCP/IP for the interchain in the next 10 years or so. It looks as if it's gaining that kind of adoption. So if you want to find me, I'm at Chjango on Twitter. And if you are looking for alpha, just go to Interchain FM or right here on Interchain Jam on the Interchain YouTube. That's a lot of interchains, or directly on the Cosmos Twitter. So, all right. Congratulations. I'll see you all next time.